I don't know why, Austin, it's only showing me a really small part of your screen.
Let me. Oh, there we go. Because the
Okay, that's better.
screen share had paused. All right. All right. Well, while we're everybody, see most people are good to go. Uh, so first thing I want to point out is I included a few links on here. One is for Levon's actual thing. They have a lot of information in here as far as basic model syntax and specific types of things. So check that out at some point. For our plotting, we're going to be using SimPlots, and as Anna suggested, we're more or less going to be sticking with some defaults. We'll put in a few arguments for specific reasons, but we're not really getting into the detailed stuff. But so I did put in this link that goes into right here are the different arguments that go into SimPlot. So as you can see, there's a ton of them, which is why we're not getting into like trying to make them pretty for now. And then this last one is just the documentation for the lav inspect, which is I just wanted to put this in here because all of these different things that you see here are all different specific bits of information that can be pulled out of the Levon object once we fit it. So as you can see, there's again a ton of stuff in these models, and we're only going to be covering a specific subset of that information. So we're not even using lav inspect, but I wanted to at least put that link in there so if you ever need to go back to this and reference it, that you have it there. Um, so to start off with here, as all the homeworks have done, what is the nature of the variables that we use in path analysis? Excellent. As Elise pointed out, we need at least one independent variable and at least one dependent variable. They can be continuous, dichotomous, or a mixture of the two. It's a rather flexible thing. What about our assumptions? What are the assumptions of path analysis? I sent out the scripts in an email this morning, Josh. Linearity, normality, etc. Similar assumptions for regressions. Yeah, so we're looking at our linearity. We need a rather large sample size. If we're estimating missing data, we got to use techniques that don't reduce variability. I'm kind of skimming over these quickly, but all this should be back in your lecture, so you can go back to it. Our residuals are normally distributed. We have univariate and multivariate normality, no outliers or multiclinearity or singularity. Our exogenous manifest variables are measured without error, and all the relevant variables are included in the model. So as far as the R stuff goes, for this particular lesson, I have the R code itself in there, because there's, as you'll see, there's very few functions that we're actually going to be doing. So this particular lab, we're really going to be focused more on understanding what it's doing. So I thought maybe with having the code in here already, that instead you could just spend your time writing notes as we go over things, as opposed to typing in, all this information. But so if we want to, we're going to start with doing a regression, not in SPSS, predicting the reading achievement, SRA, based on participants' sex, birth region, and mother education, and their socioeconomic status. So if we're just doing a regular regression, we put it in as we always have, using our LM, just SRA regressed on those 4 variables, and we give it our data frame, and we're going to create this mod LM. And then when we need to report all the information about it, just like we always have, we just run our summary. And now here's where this is what we report. Standard, regression, what we are all very familiar with. So nothing new there. So in terms of how we would write out this model, on A on the homework, it says write it out as, B1x plus B2x2 ... etc., etc. So what would be like the first couple bits of this model? What I mean is, if we were just to say, like, write out the linear equation for this model, if we were to specify this model, where B1 times x1 plus b2 times x2 plus b3 times x3, how would we interpret this particular model? There we go. Yeah, that's what I'm looking for. Anna.
Yeah, you're starting to get some good stuff in there. Casey started by saying, well, first we have the intercept, and Linda threw in right away the first couple of intercept plus the first couple of B's times their associated X's.
Exactly. Then, we'd report this as we always have, that it would be our F, our degrees of freedom, is 4 and 2124. So our F statistic is 46.26. Our R squared is also in that summary. All of our standard stuff. Now the next thing it asks for, though, is to report the standardized betas beyond just our estimates here. This is where we get into either the PSYC or LM beta packages. They both have a function called LM beta, and I went ahead and put them both in there because I didn't know if we'd run into our version dependability issues that we've had over the semester. But either way, when you run one of these, it's going to give you the same information, which is now reporting the same as it's like these estimates, only these are the unstandardized, and these are now your standardized parameters for each of these variables.
So quick question then, based on the standardized parameters, which variable right now seems to be best predicting the dependent variable? Good, Mother Ed, yeah. it's got the 0.241, which is larger than all the other ones.
Right. So now that we've run this as just a regular old regression, let's run this as a path analysis model. So here is specifying that exact same model that we just ran, only as a path analysis model. So first we specify it, as we talked about before, with this character string. Now, just for demonstration, if you were typing this out, what I would suggest doing, the way that I would write this out, is to start by giving it some object and saying mod A, put in your arrow, and then put in your single, like apostrophe marks, basically. Hit enter a couple times just to create some space in there. And now in here, in these few lines, is where you're going to enter in all your stuff. And then sorry, Morgan's asking about what do I mean by the apostrophes. That's right here. When you start, instead of doing the double quotes, use the single quotes. So same button, just without the shift. And then just hit enter a few times to create space between those to give yourself some room to work. Yeah, so the reason that we need to do that is, like we talked about in the last lecture, in Lavon, we have to specify our models as character strings. Specifying the model is separate from fitting the model, which is what we'll get into next. But right now, and so that's why I'm suggesting specifically starting it out this way by just creating whatever you want to call it, your assignment arrow, putting in your single quote marks, and then hitting enter to enter in your text strings there in between. Otherwise, if you were trying to sit here and type things out this way, it's pretty easy for that quote to get lost, or you accidentally jump over on this side of it. It just gets kind of finicky. So minor detail, but as far as the way that you would enter it, I would suggest entering in those quotes, creating some spaces between them to give yourself some working space. Does that make sense? So this first model that we're specifying, I'm just calling it mod A, and it's exactly what we specified in our regular regression model up here. Now, as far as fitting that model, we're going to be using the sim function, and we tell it for our model, we want model A, our data is df. We also will enter the argument missing equals ml, and what that does is it takes, if there are missing data in this model and this data that we're putting in, ML will tell it to use the full information maximum likelihood estimation to fill in missing values. There are different there are different things that you can use for the missing data. Not going to get into all of them. If you want to check out the documentation and see what all the different possibilities are, but there's a lot of them. So we'll just say it's sufficient for now to say this is how we impute our missing data. And then also this fixed dot x equals false. So I put in a note here that Lavon doesn't estimate the exogenous correlations, but they're taken as pre-estimated from the covariance matrix. If that doesn't make sense, all you need to know is the sentence after that, that to get the correlations in the output between our exogenous variables, you include fixed dot x equals false. If you don't do that, then it won't give you the those correlations in the summary output. So again, imputing missing data and give us the correlations of exogenous variables in the output. So I'm running that, and I'm storing that as an object called mod.pa, or just our path analysis model. Does anybody have any questions? Because after this is when we're getting into the actual summary itself. So it might be better to just cut it a couple minutes short than get started on that next chunk.
I'm wondering if we can ask people to take a look at the model that you just specified, and once again, draw it out and then send us another picture. So I think it's a worthwhile exercise. Yeah, there you go. Take a look at that and now send us the picture of what that model looks like. Don't forget to include the covariances among the exogenous variables and the residual terms associated with the endogenous variable. Josh has a question about the fix.x argument again. And it's, I think, Josh, that basically it's that Lavon is going to do the covariances, but if you actually want to get the output to include the correlations of the standardized covariance, you need to include that fix.x equals false. Otherwise, you're not going to get the actual correlation.
I don't know if it's intentional or just coincidence that it's fixed, like think exogenous, and that's, I think, the dot x as the exogenous, correlations.
Okay, so we'll look for the emails from you guys about what this picture looks like for the model that we're first running in lab. And we'll pick it up from here. We're going to actually take a look at the summary of this model the next time we come together.